2 is xi yi, second node. So we'll write the same coordinates like x and 0, x and y coordinates for second node. Similarly for x and y coordinates for third node. X distance is third node's x distance is 0 and y distance is y. Okay. Then next length, calculation of length. Length of what? Length of first member, length of second member, or we say element. Length of first element is given, that is x, and length of second member is not given. So we will calculate this length by Pythagoras, and we can write whatever the value, or directly we will write here square root of x square plus y square. So this is the length for second element. Or you can refer this formula to write, to calculate the length of next element. Then L, small l is xj minus xi upon L. Xj is what? X minus 0 upon L. Xj minus xi. Xj is x. X minus 0 upon length L. Okay. Length is what? X. X. Okay. That is 1. Actually here no values are given, only the distances in terms of x and y is written. But when you solve actual problem, there are some value, so you can take those values and get directional cosines. Next is, similarly you can write for L for second element, L xj minus xi, xj 0 minus xi 0 minus x upon L. L is square root of x square plus y square. So whatever the value you are getting, you write here. Next, M formula is given yj minus yi by L, and you can calculate the length, you can calculate directional cosine for first element, that is m. Similarly for second element, that is m. After that, L square, you just see the column of L, whatever the value you got, you just make square of its value and write here L square. Similarly, see the values of m, you go for writing m square, and Lm is what? Multiplication of these two, L and m. So directly you will write here the multiplication or the value after multiplication. After getting this total table on all values, so next step is to write element matrix equation. Total number of elements are 2, so we will write 2 element matrix equations, and the general element matrix equation is, just write EME, element matrix equation, and this element matrix equation is EA by HE. H is what? Length. H is length, or instead of H you can directly L, you can write directly L. EA by HE L square Lm minus L square minus Lm, then Lm m square minus Lm minus m square minus L square minus Lm minus lm minus m square l square lm m square into h1 v1 h2 v2, which is equal to p1x p1y p2x p2y. We know all these things. E is modulus of elasticity, A is area which is given, then h is length of element, okay. Then L square, Lm, all those m square, all those values are written from this table. So you can write here h1 is horizontal displacement at node 1, v1 is vertical displacement at node 1, h2 horizontal displacement at node 2, v2 is vertical displacement at node 2, p1x is force along x direction at node 1, force along y direction at node 1, force along x direction at node 2, and force along y direction at node 2. After writing this element matrix equation, suppose this equation is for first element, you just write all those values at the place of L square, Lm minus L square minus Lm m square, and then you go to write second element matrix equation. EME for second element. Same equation can be written EA upon HE L square Lm minus L square minus Lm, then Lm m square minus Lm minus m square minus L square minus Lm L square Lm minus Lm minus m square Lm m square. As this is second element, with continuation of node numbers, we can write h2 v2 h3 v3. As second element is lying in between node number 2 and 3, we are writing horizontal and vertical displacement at node 2 and at node 3. As we have seen before in first element matrix equation, horizontal and vertical displacement at node 1, similarly at node 2. And forces, P2x, P2y, P3x, P3y. Here horizontal force and vertical force at node 2, or the forces along x and y direction at node 3, all are shown. So after this we need to write global matrix equation, GME, global matrix equation. So here we consider the previous two equations and we are assembling here, and after assembly we will get global matrix equation. So for this purpose I write first EA by HE, common term. Then, as we know, first element is lie in between node number 1 and 2, and it has degrees of freedom 1, 2, 3, 4. So I will write here 1, 2, 3, 4. 1, 2, 3, 4 degrees of freedom have been written here. And for second element, degrees of freedom 3, 4 and 5, 6. So same I am going to write here 3, 4, 5, 6, 3, 4, 5, 6. Now after assembly, global matrix equation will become with 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6. So 6 by 6 matrix will form. 6 by 6 matrix will form, and primary variables are h1, v1, h2, v2, h3, v3. Total 3 horizontal displacements and 3 vertical displacements, and in secondary variables are p1x, p1y, p2x, p2y, p3x, p3y. Total 6 forces, 3 horizontal and 3 vertical along x and along y. So at the time of assembling these matrices, you see both stiffness matrix, like stiffness matrix for first element and stiffness matrix for second element. So how to write the elements here? 1, 1. Go to see 1, 1. Column number and row number. 1, 1. Column number and row number. 1, 1. L square is present. Here 1, 1. No. Because in the second matrix, the numbering is from 3, 4, 3, 4 and continue. Okay. So at the place of 1, you should write the value coming at this position 1, 1. So I will write here L square. Next 2, 1. So in second matrix there is no 2, 1. Only in first matrix there is 2, 1. So I will write LM. LM. Okay. If both positions are present, then we should add those values. For example, suppose 4, 4, 4, 4, m square is present here in column number 4 and row number 4, m square. Similarly here 4, 4, again here is m square. So we should write at the place of 4, 4, two values we have seen, so we should write m square plus m square. In this way you complete this global matrix equation. Now how to apply boundary conditions? If we check the given problem here, node number 1 it is fixed, so node number 1 is fixed, node number 3 is fixed. Okay, so node number 1 is fixed, so there is 0 displacement, horizontal displacement and vertical displacement. So I am writing at the primary variables h1 v1 0, h3 v3 0, and we are going to calculate